Sutra is a word from Sanskrit language and it means thread or a string. Sutra is a short, aphoristic verse or phrase that conveys a teaching or principle often used in Hinduism, Buddhism, and Jainism. It could also be a collection of verses or teachings. In English, normally this word sutra is often used to refer to ancient Indian texts such as Buddhist sutras or Hindu sutras and stuff like that. In this video, I am going to introduce you to this new project which is called as Sutra, and Sutra stands for Scalable Multilingual Language Model Architecture. Pretty interesting project because recent advancements in LLMs have predominantly focused on a limited set of data-rich languages, with training data sets being notably skewed towards English. This skew results in a significant bias, rendering LLMs less capable of understanding, processing, and generating text in languages with substantial speaker populations. Languages such as Hindi, Arabic, Bengali, Japanese, Urdu, each with over 250 million speakers, even more, constitute less than 3% of the data typically used for training these models. This enduring bias represents a substantial challenge as it is not feasible for LLMs to underperform in languages spoken by vast number of people. In light of these disparities, this work seeks to bridge the gap between market demands and the current capabilities of LLMs. And this paper is trying to mitigate linguistic inequality inherent in recent multilingual instruction following task or IFT models. The goal is to develop a model adept at performing downstream tasks in any supported language, eliminating the need for multilingual speakers to default to English for prompts. So, what is Sutra? Sutra is a novel multilingual large language model architecture that is trained by decoupling concept learning from language learning. Inspired by how humans learn, Sutra decouples core concept learning from language learning, making it scalable and easier to reach large number of languages. Humans first understand the world through concepts and then gradually learn their native language. Once fluent in one language, they learn new languages without having to relearn common core concepts. Similarly, central to our approach is the strategy of separating concept learning from language learning. This enables the core LLM capabilities to operate within a conceptual or latent space, while the heavy lifting of tokenization and translation is handled by specialized encoders and decoders inspired from neural machine translation. So their training methodology is very interesting. It has three phases. First one is concept learning. So initially what happens is the core concept model undergoes training to grasp concept within a small set of languages, which sets a solid foundation. Then comes language learning. So they train specialized neural machine translation based encoders and decoders alongside a multilingual tokenizer, which is designed to master multilingual translation. Thirdly, they have language alignment, where they perform language alignment, merging concept understanding with linguistic uh, proficiency. So, Sutra is employing a structured path during inference because input is processed through an NMT encoder, as you can see here on the screen, followed by the concept model, and finally through the NMT decoder to produce the output. If you look at the architecture, which is quite interesting, input vectors are routed to a subset of the available experts, specifically 2 out of 8 by a specialized router. The aggregate output of this layer is the sum of the individual outputs, each weighted accordingly. Each expert comprises a feed-forward module similar to those found in conventional transformer models. How good is that? So all in all, very impressive stuff here. For example, if you look at this diagram, the same this concept, like umbrella, house, dog, are the words English on the left. When expressed in different languages like English, Hindi, can be mapped to quite different embedding vectors, which you can see on the left. In order to achieve multilingual encoders and decoders which map concept in different languages to a common concept space, these embedding vectors need to be aligned in the middle. It can be seen that after the multilingual concept alignment stage, The same concept, umbrella, house, and dog, are now mapped to similar embedding vectors, even though they are expressed in different languages, which is on the right. So, in this paper, the specialized neural machine translation, or NMT based encoders and decoder, can apply the same principle to master multi-language translation and ensure concept consistency across languages. So all in all, really impressive stuff here. I think Sutra paves the way for development of phonetic models, which benefits from the clear separation between concept modeling and language learning. By replacing the NMT decoder with a phonetic decoder, they have enabled the generation of phonetic responses for more seamless integration with speech models. And according to this paper, which I'll drop the link in video's description, their next frontier for optimization is to examine the accuracy and performance impact of structured sparsity and int4 precision, which could significantly reduce Sutra's GPU memory footprint and yield with improvement in latency. So Sutra is a really good state-of-the-art multilingual conversation language model. Hopefully that the weights will be released soon, and we should be able to play around with it to see how it goes, because we really do need some diverse multilingual models there more and more in every language. So in my humble opinion, Sutra sets a new precedent for multilingual languages by delivering high performance and efficiency without sacrificing linguistic diversity in its architecture, which mirrors human cognitive development by separating concept understanding from linguistic expression, allows for a more natural and extensive language comprehension. So this breakthrough bears significant implications for the global adoption and application of AI, paving the way for more inclusive and equitable access to technology across language barrier. So I think one more thing that I wanted to mention is that Sutra can support more than 50 languages, which include languages as diverse as Hindi, Polish, Turkish, Urdu, Greek, Japanese, Thai, Bengali, Marathi, Telugu, Tamil, Kannada, Punjabi, and this few of the European one like French, Italian, Spanish. So uh, I'm not sure if they are all available at the moment, but according to the paper, there will be more languages supported in the future versions of Sutra. So amazing stuff. I'm still reading through the paper, which really sounds very impressive and very easy writing. So really hats off to all of these researchers, Abhijit, Michael, Steven, Simon, Jeevan, and Pranav. I think they have done a wonderful job here. So I'm going to spend some more time on it to see if I could get my hands on this model somehow. And then as soon as I do, I will let you know, of course, in a demo or some sort of another video. I hope that you enjoyed it. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.